Have you ever looked up at the sun and wondered how it produces so much energy day in and day out for billions of years? What if I told you that we're on the verge of recreating that same process right here on Earth? This isn't science fiction. It's the incredible promise of nuclear fusion, and it could be the key to unlocking a future of limitless, clean energy for all of humanity. So what exactly is fusion? Let's break it down. You've probably heard of nuclear fission, which is how our current nuclear power plants work. Fission splits heavy atoms, like uranium, apart to release energy. It's powerful, but it also creates long-lasting radioactive waste. Fusion is the complete opposite. It takes light elements, like hydrogen, and smashes them together under immense heat and pressure to form a heavier element, like helium. In this process, a tiny amount of mass is converted into a huge amount of energy. It's the very same reaction that powers our sun and every star in the universe. The fuel for fusion is abundant and easy to find. The main ingredients are two isotopes of hydrogen called deuterium and tritium. Deuterium can be extracted from ordinary seawater. In fact, the amount of deuterium in just 1 gallon of seawater has the energy equivalent of 300 gallons of gasoline. Tritium is a bit rarer, but it can be produced from lithium, which is also found in abundance in the Earth's crust and oceans. This means we have enough fuel to power our planet for millions of years. Now imagine a power source that produces zero carbon emissions. Fusion doesn't burn anything, so it doesn't release greenhouse gases that contribute to climate change. And what about safety? Fusion reactors are inherently safe. Unlike fission, there's no risk of a meltdown. The fusion reaction is incredibly difficult to sustain. If anything goes wrong, the reaction simply stops. The main byproduct is helium, which is a harmless, inert gas. You can put it in balloons. So if fusion is so amazing, why aren't we all using it right now? Well, there's a huge challenge. To make fusion happen, we need to recreate the conditions inside the sun. We're talking about temperatures over 100 million degrees Celsius that's more than 6 times hotter than the sun's core. At these temperatures, matter turns into a superheated, electrically charged gas called plasma. And of course, no physical container on Earth can withstand that kind of heat. This is where some truly brilliant engineering comes into play. Scientists have developed a device called a tokamak. It's a donut-shaped machine that uses powerful magnetic fields to contain and control the superhot plasma. Think of it as a magnetic bottle, holding the mini-sun away from the walls of the reactor. This magnetic confinement is the leading approach in the global race for fusion energy. Right now, a massive international project called ITER is being built in the south of France. ITER stands for International Thermonuclear Experimental Reactor, and it's one of the most ambitious science projects in human history. 35 nations are collaborating to build the world's largest tokamak. Its goal is to prove that fusion can be a viable large-scale energy source. ITER aims to produce 10 times more energy than it consumes, a critical milestone known as net energy gain. But ITER isn't the only game in town. All around the world, from government labs to private startups, brilliant minds are racing to crack the fusion code. We're seeing different approaches, like using powerful lasers to ignite a tiny fuel pellet in a process called inertial confinement. In December 2022, the National Ignition Facility in California made history by achieving fusion ignition for the first time ever, producing more energy from fusion than the laser energy used to start it. This was a monumental breakthrough that sent shockwaves through the scientific community. The progress is accelerating faster than ever. Private companies, backed by billions in investment, are building smaller, more agile reactors. They're using new materials, advanced computing, and artificial intelligence to speed up development. Some experts believe a commercial fusion power plant could be online as early as the 2030s. Let's think about what a fusion-powered world would look like. It would mean clean, reliable electricity for everyone, everywhere. Developing nations could leapfrog fossil fuels and build sustainable economies. We could power massive desalination plants to provide fresh water to arid regions. We could even fuel interstellar travel, taking humanity to the stars, powered by the same energy that makes them shine. This isn't just about keeping the lights on. It's about fundamentally transforming our civilization and our relationship with our planet. It's about solving some of the biggest challenges we face, from climate change to energy poverty. The journey to fusion energy is a marathon, not a sprint. There are still immense scientific and engineering hurdles to overcome. But for the first time in history, the finish line feels like it's in sight. The dream of harnessing the power of the stars is closer than ever to becoming our reality. The race for fusion is on, and it's one of the most exciting and important stories of our time. It's a testament to human ingenuity and our relentless desire to build a better future. Thanks for watching, and if you're as excited about the future of energy as I am, make sure to follow for more.